Thank you so much for joining this lesson. We shall be continuing with the Alliance Mathematics Forum examinations. We've already discussed the paper 2, and we are now on the paper 1, section 1. So we start from number 1. This is a very good paper. You can get these models from 0704 1533 66 together with the marking skills. Solve the problem below, leaving your answer in standard form, correct to 3 significant figures. Look at that. Correct to 3 significant figures and also in standard form. So we have 2 specific instructions and we have to adhere to both. So let's work out this, beginning with the numerator. When we take 100,000 and we divide by 5, this gives us 20,000. Then we are supposed to add, we work out first what is in the brackets. So 50 multiplied by 43 and 41 added gives us 84,000. Then this should be divided by 7. We multiply by 1/7. So 50 times 84,000 divided by 7, that gives us 600,000. So we have 20,000 and 600,000. So we have 620,000. Yeah. Then we check now the denominator. What's in the denominator? We have in the brackets 8 minus 5, which is 3, plus 8 divided by 28 divided by 2, which is 14. So that takes us to 17 from the denominator. So the combined now, for us, we get the answer, 620 out of 17. So what does this give us? I'm getting 36,470.588. Yeah, 588. At this point, something that we should notice is that we are not yet at the answer, simply because we have to check and write our answer first in standard form. So let me put it in standard form. We have 1, 2, 3, 4. So 3.647 times 10 to the power of, we said 1, 2, 3, 4, 10 power 4. Then now we make it, yeah, like that now. We make it 3 significant figures that way. Times 10 to the power of 4. Yeah, like that. Number 2, the sum of interior angles of 2 regular polygons of sides n and n plus 2 are in the ratio 3:4. Calculate the sum of the interior angles of the polygon with n sides. So we can check polygon 1. How do we get the sum? Remember, generally, sum is usually given by 180 n minus 2, where n is the number of sides. Therefore, for the first one, the number of sides is n. So 180 into n minus 2. That will give us the sum. Then for polygon 2, we will have still 180 into number of sides, which is n plus 2 minus 2. So we have the whole of this is in the place of n, because the number of sides for that second polygon is n plus 2. So instead of n, we write now n plus 2, then minus 2, according to the formula. So now we are told these two sums are in the ratio 3:4. So 180 into n minus 2, when we divide by 180 into n, we should get the ratio 3:4. The reason why I'm writing n is because now the +2 and the -2 shall cancel one another. Then now 180 cancels because it's appearing both in the numerator and also in the denominator. We cross multiply now. 4 multiplies everything here. So that 3 multiplies n. When we group terms, we shall have the value of n becoming 8. So if n is 8, then we can get the sum now of interior angles. 180 into n minus 2. So 180 into 6, this gives us 1080 degrees. So that is the sum of the interior angles for the polygon with n sides. Look at number 3. A curve has a turning point at point -1, 1. Given that the gradient of the curve is, this is the gradient of the curve, find the value of A and the equation of the curve. So for us to proceed here, we are supposed to know that 1 gradient function, this is dy dx. This is the differentiated function. Minus 12. That is the differentiated function. Then we should also understand the meaning of a turning point. At the turning point, gradient is usually equal to 0. And the turning point is at this point. So, in other words, the examiner is trying to mean when the value of x equals to -1, that's according to the coordinate, the value of gradient equals to 0, because that is a turning point. So 6, we substitute -1 squared plus a -1 minus 12 should give us a gradient of 0. So with this now we can find the value of a. So this is 6 minus a minus 12 equals to 0. Negative a minus 6 equals to 0. Negative a equals to 6 and a equals to -6. If a equals to -6, then the gradient function can now be written in a specific manner. 6x squared, instead of a now we have -6x minus 12. This is now the gradient function itself. Now with gradient function, we can find the curve itself. What shall be y if the gradient function is this? Given the gradient function, we integrate for us to get the function itself. If it was the function to get gradient function, we would have differentiated. But now it has been differentiated. We want to get back. So we do what we call antiderivative. Yeah, the integration. So integrating these from the first term, this one, when we integrate, 6x power 2, the power of x increases by 1, that becomes 3. So x is now power 3, and the new power divides everything. So 6 divided by 3 becomes 2. Minus, here we have a -6x, so the power of x becomes 2, which increases by 1, and the new power divides, so this becomes 3. Minus 12, x is introduced, then the arbitrary constant integration. With the general equation of the curve, we can find specific curve just because of the provided coordinate here, whereby we will say with the coordinate xy, it means when x is -2, y is 1. So y is 1 when x is -1. So 2 to -1 cubed minus 3 into -1 squared minus 12 into -1 plus c. So we can work this one out. -1 cubed, -1 squared, 12 into -1. Yeah, so we are having 1, 7 plus C. How shall you remain with C? -6, like that. If the value of C is known, we can now write the specific equation of the curve. Y equals to 2x power 3 minus 3x squared minus 12x minus 6. Yeah, the value of C has already been discovered. So we write it like that. A very good question. Look at number 4. Using a ruler and a pair of compasses only, construct a rhombus ABCD such that the length of AB equals to 5 centimeters. And the angle BCD equals to 127. Yeah, 127. All right. So let's check with a ruler and a pair of compasses only. We construct a rhombus. So I begin by doing the line AB, 5 centimeters. So I stand at A. Then I measure 5. And remember, it's a rhombus, right? Yeah, it's a rhombus. So that's 5 centimeters. Now, the next thing is ensuring that I construct 127 degrees, and that is the angle at C. I want you to see how technical the question is. Then we proceed to construct it. It's always good for you to operate with a sketch. Okay? It's always good for you to sketch a diagram. Look at this. Yeah, this length is parallel to this one. And we need the angle. If this is A, B, C, D, we need the angle at C to be 127.5. So if that angle is 127.5, then that translates to the angle at B to be equal to 180 minus 127.5, giving us 52.5. So the angle at B should be 52.5 degrees. Reason being, the co-interior angles are usually supplementary. So the angle at C and the angle at B should add up to 180. So now we need the angle at B to be constructed. How do we construct 52.5? How do you construct 52.5? You can use several approaches. Remember, without a protractor. Remember, this is happening without a protractor. Therefore, you can start by raising a perpendicular at B. Just make arcs like that. Then you produce a line to B. That's a perpendicular line. 90 degrees. What about with this 90 degrees? What if now, what if with 90, we construct a 60? We construct 60 degrees. So look at the 60, the way I shall construct it. I just want to construct some 60 degrees somewhere, because my intention is to get 52. So we can say that with 52, we may need 45. Let me check the difference between, oh yeah. So we can first bisect the 90 here because of 90 bisected to give us 45. That's 45. Then after 45, you know what has remained is also 45. Yeah, what has remained is also 45. But now, if we construct 60, this is 45. Then now we construct again 60. From B, we construct 60. Construct 60 like this. So starting at that point, yeah, produce 60 like that. Look at these now. 45 and 60. 45 then 60, which means the overlapping angle from 60 and 45. The overlapping angle is 15. The overlapping angle there is 15. So what if we bisect 15? Remember, we are not supposed to measure. We just bisect this 15. So standing at B, we make an arc and also an arc. Then we make arcs like that. You see, 15 has been bisected. Now we produce now with a lot of confidence like that. Look at my measurements now. Just look at my measurements. Look at my angles now. We talked about 45. And now we have bisected 15. So this gives us 7.5, meaning that the whole of this is what provides 52.5. Yeah, 52.5. So now we can stand at B and measure 5 centimeters also, because all the lines are supposed to be equal within a rhombus. They are supposed to be all equal. Yeah, they're supposed to be all. So I mark off with 5 centimeters like that. So that's 5 centimeters also, and it gives a C. Then now we are supposed to stand at C with the same measurement, and we make an arc here, the same measurement of 45, okay, or 5 centimeters. We make an arc. Then using the same measurement, we cut the first arc like that. And now we can complete the diagram. Oh, this becomes our D. You see now? See? We're having our rhombus completely constructed. So if we bisected 52.5, automatically, the angle at this point now, automatically the angle at this point becomes 127. Automatically. Like that. Yeah, like that. So that's the construction. We also told to drop a perpendicular from D. Perpendicular from D to meet BC at N. So at D to meet BC. That means while standing at N, we can drop a perpendicular. So you stand here and you make arcs. Let me show you. This one is already produced. So you stand at D and you make arcs like this. Then you stand on those arcs to make other arcs, either beyond or here. And now you drop the perpendicular line. Yeah, so that's a perpendicular dropped from D to meet BC at a point N. Then you measure the length of your perpendicular strictly up to point N, like that. Number 5. Now, vectors P, Q, and R are represented, and we can see them. P, Q, and R. On the grid, show the resultant vector P plus Q minus R using point O as the origin. So from point O, we first draw P. P is within 3 and 2 upwards. That's P. Vector P, drawn like that. Then we attach the tail of Q to the head of P. That is the meaning of adding. So we add Q, whereby we shall move through 3 and 1. Yeah, through 3 and 1, like that. So this will be vector Q, like that. Yeah, vector Q like that. Then finally, about R, we are going to subtract. So we shall not add R, we shall subtract it. Meaning that to subtract R now, subtracting R means, you know, R is 1 unit. Sorry. Yeah, R is 1 unit and downwards 3. So to subtract means 1 unit to the right, 1 unit to the left, yeah, and 2 upwards. 1 to the left, 2 upwards. So subtracting means this, like that, and then 2 upwards, like this. So now we shall attach R in the opposite way. In the opposite way. So let me attach it such that by the end of the day, I will have gone 1 unit to the left and 2 upwards. So I will attach it this way. That will be minus R now. Yeah, R in the opposite direction. That way. So now the resultant vector is here. Let me use black to show you the resultant vector. From where we started to where we are ending. That is now the resultant vector. Yeah, like that. The resultant vector. Number 6. Now, given that 3 power 5x minus 2y equals to 243, and that 3 power 2x minus y equals to 3, calculate the values of x and y. The first thing, you express composite numbers using the least base possible. So 3 power 5x minus 2y equals to 3 raised to the power of 5, like that. Now that the base is the same, from this we can extract a linear equation by equating the powers. Because the bases are already the same, we can equate the powers like that. So we have equation 1. Then from the second here, we have 3, 2x minus y equals to 3 power 1. Bases are the same, so 2x minus y equals to 1. We have equation 1 and 2. We can solve now simultaneously to get the values of x and y. How do we solve this one? You can prefer to use the elimination method, substitution method, the matrix method. Let me use the elimination method. So with the, okay, elimination will take us a lot of time. We can choose the substitution, whereby from equation 2, we can express y. Y equals to 2x minus 1. That is from equation 2. So that equation 1 is rewritten 5x minus 2, and instead of y, 2x minus 1, this is equal to 5. So 5x minus 4x minus 2 equals to 5x equals to. It's good for you to know that in the opening of brackets, this becomes 2. Okay, 2x by 2 becomes negative 4x, but 2 by 1, they are both negative, so we get a positive there. So the value of x now shall be 5 minus 2, which is 3, meaning that y can be obtained very quickly to. So the value of y is 5, like that. Number 7. Now, given the coordinates of A and B as 4, 2 and 8, 2, respectively, find the equation of the perpendicular bisector of AB. First thing, you're supposed to know that the line AB together with its perpendicular will have the product of their gradients, giving us -1. So let's get the first gradient of AB. The gradient of LB shall be 2 minus 2, change in y, over change in x, 8 minus 4. So this now shall be 0 over 4. Let me have it that way, 0 over 4, yeah? Then now we can talk about the gradient of the perpendicular line, which is our gradient 2. You know that gradient 1 times gradient 2 should give us -1. So times unknown gradient 2 should give us -1. So gradient 2 shall be -4 over 0, like that. Yeah, -4 over 0. So now we express this now. Where is this line passing? This perpendicular line is passing through the mid of AB, simply because it's a perpendicular bisector and we have coordinates of A and B. Then this perpendicular bisector passes through the mid of AB. If it passes through the mid of AB, then we shall have the midpoint calculated. So the mid of AB shall be equal to, we take the first x, 4 plus 8 divided by 2. Sorry. 4 plus 8, we divide by 2. Then 2 plus 2, we also divide by 2. So this midpoint is going to be 12 over 2, 6, then 2. So this line passes through the coordinate 6, 2, and we can express the gradient. Change in y, change in x, cross multiplication, 0 equals to -4x plus 24. So 4x equals to 24, giving us x as 6 as our equation. So the equation is x equals to 6. That is the line x equals to 6. Number 8, a farmer has 1200 meters of metal railing to form 2 adjacent sides of a rectangular enclosure, the other sides being live fence forming a right angle. Find the dimensions which will give the maximum possible area. So we need to say that in our rectangular enclosure, let me try to sketch it. In our rectangular enclosure, this way, The rectangular enclosure is that way. We can have X and Y. Then we will say, according to the length here, which is supposed to fit on two adjacent lengths, then X plus Y should give us 1200. And from this, we can express Y, right? Y expressed becomes 1200 minus X. Then we can say maximum area equals to length times the width which has been expressed. Area equals to 1200 X minus X squared. If that is area, then we'll say at maximum area, the derivative of area with respect to X should be 0 at maximum area. Therefore, we will have the derivative of area with respect to dimension X, whereby now we are having 1200 minus 2X. So 1200 minus 2X equals to 0. 1200 equals to 2X. The value of X becomes 600 meters. Find the dimensions which will give maximum possible area. Then Y shall also be 600. So 600 meters by 600 meters is the area, is the dimension for area maximum. This is called maximum. Yeah, we call it maxima in differentiation. Look at number 9. A very good question. The velocity of a particle after t seconds is given by v equals to t squared minus ut minus 2t plus 4. Use the mid-ordinate rule with 6 strips to estimate the displacement of the particle between t equals to 1 and t equals to 12. Now, in case we use intervals of 1, look at that. In case we use intervals of 1, we shall obtain 12 strips between 1 and 13. But now we want the strips to be only 6. So we shall use intervals of 2. We shall use intervals of 2. So in the strips now, we will have from 1 to 3, then 3 to 5, 3 to 5 to 7, 9, 11, up to 13. But now look at the formula that we use, the mid-ordinate rule. So we can find the mid-heights of this particular area. You know, in case velocity against time are plotted, we will come up with a certain curve with area. A certain curve with area. So we need values of t at 2, because from 1 to 3, we need the middle value, mid-ordinate. So we need 2. Then 3 to 5, we need 4. 5 to 7, we need 6. Then 7 to 9, we need 8. 9 to 11, we need 10. And 11 to 13, we need 12. So these are the values of t we shall use. So we check at 2, what is the value of v? We substitute, and that will give us 4. We also substitute t equals to 4 in the equation. You get 12, 28, 52, 84 when we substitute 10, and 124 when we substitute 12. Then now we will talk about area given by interval into the first ordinate, the second ordinate, all the way up to the last ordinate. So h is the interval, and we are using intervals of 2. Then the first height plus 12 plus 28 plus 52 plus 84 plus 124. So this will give us a total of 608 square units. (608 square units. Area by the mid-ordinate rule. A very simple thing. Number 10. An exportable sterling pounds equivalent to 1,174.15 Kenya shillings. After settling bills worth 505.5 sterling pounds, of course, he exchanged the balance to euros. If he purchased goods worth 980 euros, calculate his balance in euros. Then the exchange rates are shown here. So 1 sterling pound equals to 1 sterling pound is equal to 175.3 Kenya shillings. What about when Kenya shillings are 1,174.15? So you divide by 175.3. This shall give us this gives us 5705.5 sterling pounds. Then this particular exporter is going to settle bills worth 505.5, meaning that the initial balance shall be when you subtract, you'll get 5200. Then after this now, we are converting to euros now, whereby we are saying 1 sterling pound equals to 1.15 euros. What about 5200 sterling pounds? It shall be 1.15 times 5200. This gives us 5980 euros. So after getting these euros, she's again going to purchase goods worth 980. So what is the final balance now? 5980 minus 980, giving us exactly 5,000 euros. Yeah, so the final answer in euros should be 5,000. A very good question. Now we are looking at number 11. In the figure below, PQRS is a trapezium with QR parallel to PS. QR equals to 6 centimeters, QS 9, this is 9. Then RS 4 centimeters, PS 10, as you can see on the diagram now. Calculate the size of angle SQR. This is the angle. We can let it be maybe alpha. Yeah, that. So to get the angle, remember in triangle QRS, the 3 sides are known. Therefore, we can apply what we call the cosine rule, whereby if we take Q squared, you get the same as R squared plus S squared minus 2 RS, the cosine of the angle at Q, which is our alpha now. So Q squared is the angle, is the length opposite to that. equals to r squared, which is the angle opposite to the line opposite to r, 9 squared, plus s squared, the length opposite to s, 6, minus 2 multiplied by 9 by 6, the cosine of the angle at Q, which is alpha in our case. So let me compute all these now. 4 squared minus 9 squared minus 6 squared, getting negative 101 equals to negative 2 by 9 by 6, so negative 108. So the cosine of alpha shall be, when you divide through, get 0.9352. And now from there, we can get the angle by computing cos inverse. This gives us 20.74 degrees, like that. So the angle is 20.74. Area of triangle PQS. Now, because PQ, all right, PR is parallel to PS, then the angle alpha that we've calculated is alternate to these, and alternate angles are usually equal. So now we can use half times one side, 10, times another side, 9, then cos a sine of the angle between them. So sine of 20.74. This shall give us this shall give us 15.94 square centimeters, like that. 15.94 square centimeters. So that is how number 11 is supposed to be worked out. A very good question. Looking at number 12 now. From a point on the ground, the angle of elevation to the top of a flag post is 35 degrees. Then from a point 30 meters closer to the base of the pole, the angle of elevation is 50. Calculate the height of the post correct to 1 decimal place. When you're provided with information like this, it's always prudent to sketch the information into a diagram. Now, from a point, the angle of elevation is, let me show you how to maneuver through these. These are horizontal graph. We have a flag post somewhere here. Then from a point, the angle of elevation is 35. This angle is 35, maybe from point A. Then as you move 30 meters closer, you arrive at a point B. The angle of elevation is now becoming 50 at a point B. What is the height h? We can let this distance be x. So that we say, applying trigonometry here, we talk about the tan of 35 being equal to opposite out of adjacent length, 30 plus x. You see that? So that from this, the value of h equals to tan 35, 30 plus x. Then we also express again the tan of 50 is equal to h over x, meaning that the value of h can be given by x tan 50. That way. Because we have two expressions for h, then we can equate them. We say x tan 50 equals to tan 35, 30 plus x, like that. So tan 35 equals to 0.7 . 0 0.7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 0 .7 . 0 That should be tan 50, sorry. We're beginning with tan 50, eh? So the tan of 50 equals to 1.192x equals to tan 35 multiplied by 30, giving us 21 plus 0.7x. So we can group terms to remain with 21 here. Then we have 1.192 and a 0.7, giving us 0.492x. How do you get x? We divide 21 by that value, 42.68. meters. So if x is known, then we can find h using the latest expression here. For h, we need 42.68 tan 50. Yeah, this gives us tan 50 multiplied by 42.68. This gives us 50.86. So 50.86, we make it 9 meters because we've been told to 1 decimal place. So that one is already worked out. 13. The figure below, OCPQ, is a semicircle of radius 6. Now with center O. CPR is a sector of the circle with center C. The angle POQ is a third pi radians. Find the area of the shaded region. So we have several areas here, and we have to work them out. First, we can convert the angle at this point to degrees Celsius by just remembering that 2 pi radian should give us 360 degrees. Then here we have a third pi radian. What shall this be equal to? A third pi times 360 out of 2 pi radians. So this is going to be exactly 60 degrees. So we have an angle of 60 degrees there. So the first thing that we're going to find now, after knowing the angle there, we should know that the other angle now is 120. Yeah, like that. If radius is 6, then need a 6 here. This is also 6 from O to Q. Yeah, that way. Then we can first find the angle of the whole region, area of CPQ. The whole area CPQ, all that area, whereby we need sector OPQ, and we add triangle CPO that way. So let's get all the area there. This sector we need 60 over 360 pi. Have we been told the pi to use? No. So we can use pi r squared. Then we add, for the triangle we need a half, one side, another side, and sine of the angle between them, that way. So now we have 60 over 360 multiplied by 3.142 by 36, giving us 18.852. Then we add half multiplied by 36, the sine of 120, giving us 15.8, no, 588. Yeah, 0.588. So now we combine these and we get 34.44 to 2 decimal places. Then after getting such area, now we can subtract from the whole area. We can subtract another sector here, which is sector CPR. So we need to subtract sector P, CR. So look at this. We are having 120 here. It's the angle. So we can bisect the triangle here. Set the triangle there. And how? It's good to remember that this is 6, and this angle is now becoming 60. So with 60 and 6, we can get the length here, the length x, whereby we shall say, let's apply sine. Sine 60 can be given by opposite over hypotenuse. So x shall be 6 sine 60. So 6, the sine of 60, gives us 5.196. 5.196 centimeters. What about the radius CP? What about radius CP? We multiply this by 2, then 10.39. Yeah, 10.39. It's also good for you to know, if this is right angled and this is 60, then this automatically 30. So for the sector CPR, for the sector CPR, we need 30 over 360 pi r 10.39 squared. This gives us 28.27. 28.27 square centimeters. So we have area of the region CPQ found here, and also the area of the sector CPR. When you subtract the two, we shall get this shaded. So let's now subtract for us to get the shaded. 34.44 minus 28.27. 28.27. This gives us 6.17 square centimeters. Wow, this is a very interesting question. You are supposed to think big, think broadly for you to arrive at such an answer. 14 now. Use tables of square root, cubes, and reciprocals to evaluate the square root of 426.8 plus 4 out of the cube of 0.2368. Let me begin this way. To find square root, we need to write in standard form first. 4.268 times 10 to the power of 2. Yeah, we're finding square root. So this becomes 10 power 1. You know, I shall answer every term separately. So what are we getting there? We are taking the square root of 4.268. 4.268. Let me take you to the 4-figure tables so that we may read every value as the examiner wants it. So this is the 4-figure table. We need square roots. So we go to the tables of square roots. 4.268. This is a square roots. Yeah, 4.268. So 4.2, we first establish the column. 4.2, we establish the row that we shall be using. That is the row that we shall operate with. So 4.268. So 6 at 6. The column with 6, we get down through that, which is this one. So we're having 2.0640. 2.0640. 2.0640. Then because of 8, we have to proceed and check the differences. Where there is 8, we add. So the column with 8 now will give a 19 at that point. So we add 19 there. We'll have 2.0659. 2.0659. 20.659. 20.659. We are done with the square root part. Now we proceed to cubes. I want us to cube 0 point. So we write standard form. 2.368 times 10 power negative 1. We are cubing. So this shall be times 10 power negative 3. We raise the power. We multiply the power by 3. Remember, to get square root, I divided the power by 2. So like that, then the cube of 2.368 should be read from the tables. Yeah, 2.368. So we go to cubes. Get to cubes. 2.3, then 68. So 2.3 is here. 2.368. So it's this is it. 13.144. That's 13.144. Then we add whatever is at the column of 8, because it is 2.368. Yes, so 68 is here. 132. 132 should be added there. 672. 13.276 that way. So we have 13.276. This will be written as now 0 point, after cubing, 0.13276. Yeah, that is it. That's it. Like that. So now we can proceed to find what we call now the reciprocals now. So now we are finding the reciprocal of whatever we've just concluded. Now we have 4 into 0.1013276. So this is what we are finding reciprocal for. 4 into the reciprocal of this, we first write standard form as 1.32. Instead of 76, we can have 8 times 10 power negative 2, like that. So 4 multiplied by 1.3 to 8. 1.3 to 8. 1.3 to 8. So for reciprocals, we're going to 1.3 to 8. 1.3 to 8. So 1.3 is here. Then 2. So 0.7576. 0.7576. Then on the differences side, we check the column with 8. So the column with 8 is here. This is a 44. So you should note that for reciprocals, it's a subtraction. So we subtract 4 here. We get 2, 3, 5, 7. So we have 0.7532 times 10 to the power of 2. When we are finding reciprocal, 10 power negative 2 just becomes 10 power 2. That is the meaning of reciprocal at that point. And now computing this shall be 4 multiplied by 0.7532 times 10 power 2. That gives us 301.28. And now we can, remember we did this, and now we have gotten this. So we can add now to get the final answer. 20.659 plus 301.28. This gives us 321.939. Yeah, 939. That way. Very good question. Look at number 15. Represent the following inequalities graphically. X less than or equal to 1.5. You know, that makes it just a vertical line. X equals to 1.5. And it's a complete line. So at X equals to 1.5, we do a vertical line there. X equals to 1.5, 18, 1 and 2. We just do a vertical line. X equals to 1.5. You mark it there. Proceed to the next. The next is also going to be a complete line. Look at the nature of the inequality there. Less than or equal to. So for that one, we establish the borderline, which is 5y equals to 3x plus 15. Then we start by a table of values, x and y. When x equals to 0, what shall be y? We substitute 0 where there is x. 5y equals to 0 plus 15. So what about when y is 0? X shall be negative 5 because of, just substitute. We discover that 3x becomes negative 15. So 0, 3, and negative 5, 0. All right, the examiner has already established some coordinates here. So we don't have x as negative 5. However, we can try some other, we can try some other coordinate, like when x equals to 3, 5y equals to 9 plus 15. We're getting 5y is 24. So that y equals to 4.8. So y equals to 4.8. When x is 3, y is 4.8, like that. So 4.8 is a point this 3, 4.8. That is the coordinate. So we can draw the line now. So we have said it's a complete line. Let's look at that. The last one, 5y equals to, this one is going to be a dotted line, negative 4x minus 20. So a table of values when x is 0, what shall be y? Everything here becomes 0, and the value of y shall be negative 4. Then what about when y is 0? What shall be the value of x? So it shall be 4x being negative 20. So that x is negative 5. Again, negative 5, 0. So negative 5, 0, which is here, and 0, negative 4, which is here. So we can now connect the two coordinates and come up with our inequality. Should be dotted because of the nature of the inequality sign. Yeah. So you see, when the three inequalities have been plotted, they have automatically shielded a common region. Therefore, you are supposed to shade now the outer sides because you've already established a common region bounded by the three of them. So you shade the outer sides of the border lines. So this is the region satisfied by the three inequalities. At 16 now, right? The table below shows the masses of 40 students in a Form 4 class. State the model class, then calculate the median mass. First, let's get the value of x. 4 plus x plus 15 plus 8 plus 3 should give us 40 because the masses for 40 students. So x equals to 40 minus, we are having 4, 15, 8, and 3. That's 30. So x is 10. So this one is 10. State the model class with the highest frequency. That is the class with a frequency of 15. So class 50 to 55. That is the model class. Then we find median. Median is usually given by lower boundary of the median class plus n over 2 minus cumulative frequency just before out of frequency of median class divided by class wing. So we can establish cumulative frequency column here. We start with 4, then 4 plus 10, 14, 14 plus 15, 29, 29 plus 8. This gives us 37 plus 3, 40, like that. So total frequency is 40. We divide it by 2 first to get 20. So the 20th student is the one with the median mass. So if it's the 20th, then we consider the cumulative frequencies for us to establish the class that carries the 20th student. This is 4, this is 14, then here 29, meaning that the 20th is within this class. So the median class is the class 50 to 55. Yeah, 50 to 55, that way. So now we apply median formula. Lower boundary, we need 50 plus the previous limit of 50, and we divide by 2, we get 50. When you look at the data keenly, you discover that this is continuous data. And with continuous data, the limits are also the boundaries. N over 2 means 40 over 2 minus cumulative frequency just before the median class, which is 14, out of frequency of the class, which is 15, multiplied by the class length, which is 5. 50 plus 20 minus 14 multiplied by 5 over 15, giving us exactly 2. So we have a median of 2. Yeah, a median mass of 2. Please remember our holiday programs here, the one-term ahead program. During the December holiday, we shall be covering term 1 work of 2026, and we are inviting all the continuing students in junior school and also in senior schools. You can reach out through our number, which is already attached on the board, 070415 3366 for more consultations. Thank you. See you again.